Good evening, everyone. Welcome to this, I think, last lecture for your X-rays. We will be finishing your X-rays in today's class, and from tomorrow we'll move on to the topic which all of us probably have been waiting for. We'll move on to electrostatics, and we'll try and cover your electrostats from the very beginning because it will take a lot of time for me to cover this because all the topics are related to each other. So once I start with electro, the last topic would be EM waves. So we'll have to cover all those 7, 8, 9, 10, whatever chapters are there. That will start from tomorrow in all probability. We'll finish with this X-rays and then we'll come back on modern physics and we'll cover the remaining topics of modern physics after we are done with electro. Anyways, we were dealing with the types of X-rays. What are the types of X-rays that we have discussed? Tell me. Huh? Or the type of X-ray that we have discussed? No one remembers them. What are the type of X-ray that we have discussed?
Hard X-rays, soft X-ray.
Hard X-ray and soft X-ray. What are hard and what are soft? Huh? Which one
Hard
is hard?
X-rays, more penetration power.
Okay. Hard
Soft
and soft.
X-rays, less penetrating power.
Soft X-rays less penetrating power. Hard X-rays more penetrating power. Given. Anything else? Any other type of X-rays?
Frequencies.
Which one?
Hard X-rays have more frequency.
Okay, hard and soft done. What about the other? Any other X-ray that we have heard about?
Continuous X-rays.
Continuous X-rays, and the other one are known as? One is continuous, the other one is known as characteristic X-rays.
Characteristics.
So continuous X-rays, we had seen that above a certain minimum wavelength, you see all the wavelengths and it is continuous because the electron is continuously losing energy. Yes or no?
Yes, sir.
We saw that. We saw the minimum wavelength, how we can find out this minimum wavelength. This minimum wavelength is directly proportional, inversely proportional to the stopping potential. If the operating voltage, not the stopping potential. If you increase the stopping voltage, the minimum wavelength will decrease. Yes or no? No, yes.
Yes, sir.
We had seen the different graphs. There are 4 types of different graphs between frequency and operating voltage, between log of frequency, stopping voltage, between minimum wavelength and stopping voltage, and log of minimum wavelength and stopping voltage. Yes or no?
Yes, sir.
Then we had seen this one more graph between operating voltage and between wavelength and intensity at different operating voltage. We have seen that when the operating voltage increases, wavelength decreases. Then we moved on to, now remember, this continuous wavelengths, continuous X-rays does not depend on the type of the metal. It only depends on what? The operating voltage. Do we remember this?
Yes, sir.
Then there is one type of X-rays which depends on the type of the target metal. And what is that?
Characteristic X-rays.
That is characteristic X-rays. And how are these characteristic X-rays produced? When this electron is hitting the target metal, it can make an electron to leave its inner shell. Then electrons from the outer shell are going to occupy space KLMN. Do we remember this KLMN series? Then in K series, we have alpha, beta, gamma, depending on from where the electron is making the jump. We remember this?
Yes, sir.
This characteristic X-rays does not depend on the operating voltage. They depend on the type of metal. And we have seen K alpha, K beta, K gamma. We had seen how to find out the value of K alpha, K beta, K gamma. Yes or no?
Yes, sir.
And then we had seen this spectrum where we had seen the entire spectrum that we obtained from a X-ray from a Coolidge tube. The part that is green is continuous X-rays. Do you see these continuous X-rays?
Yes, sir.
These continuous X-rays only depends on the operating voltage. It does not depend on the type of the metal. Then we see the spikes. These spikes depends on the target metal and it does not depend on the operating voltage. Yes or no? No, yes.
Yes,
That
sir.
is where I think we took a break. The next graph that we are going to understand. Remember, this chapter is all about graphs and groups. So the more the graphs that we understand, the better it will be for our future. And this is the next graph. This is the next graph that we have to understand, and it comes on your screen now. Do you understand? Do you see this graph? Do you understand what is meant by this graph? In this graph, what is happening is we have plotted what? We have plotted wavelength lambda and intensity. This is the same graph that we had shown in the last class. Wavelength lambda is here, intensity is I is here. We have plotted it at the same voltage. You can see it is plotted at the same voltage V. Since it is plotted at the same voltage V, you can see this lambda minimum is same. Do we understand this?
Yes, sir. Yes, sir.
But what you can see is it has been plotted for two different metals. The blue metal is Z with atomic number Z. Whatever color this is, brown metal is Z dash whose atomic number is less than Z. Now this could come as a question in your JEE Advanced because it is probably higher than the level of JEE Main. I think so. Now you can see how does the graph change. For this metal Z, which has got a higher atomic number, the graph goes like this. It is on the lower side. It's lower than the graph of Z dash. And this is the graph of Z dash. So the graph of the metal which has lower atomic number is higher. Do we see this? This has gone. Above it saying bye bye. Bye bye. I'm going. Don't worry about me. Huh?
Understanding, sir.
Pakka no?
Yes, sir.
As I told you, this chapter is all about graphs, my dear friend. The more the number of graphs that you understand, the better are your chances. That is why I am showing you all the graphs which are possible in this universe and any other universe that you know about. Are we done with that graph? Yes or no? No, yes. Huh?
Yes, sir.
I was looking for one more graph. Where is that graph gone? Okay, this one. Yes, this one. Huh. Then comes this graph, my dear friends. Again, three different graphs for continuous X-rays drawn. Two graphs drawn at the same voltage. Two graphs drawn for different metals. If the voltage is more, the minimum wavelength is less. Do we understand this? Yes or no? No or yes?
Yes, sir.
Okay, I hope you are making, you are understanding and making sense of what is being taught here.
Yes, sir.
Okay. Shall we move ahead?
Yes, sir.
Now, this is a graph between the different series of a same metal. So you can see where does your alpha, where does your gamma, and where does your beta series lie. I think I showed you this graph in the class last day. Anyways, even if not, here is the graph. One graph for one metal. Remember, the first spike is because of K beta. Then it is K alpha. So K series first comes first. Then comes your L series. Then will come your M series, and then will come your N series. Do we understand this?
Yes, sir.
Then the last wavelength for K series, the last, I mean, depending on which is coming from higher orbit, gamma comes from the highest orbit. Therefore, gamma will come first, then beta, and then alpha. Do you understand the pattern?
Yes, sir.
That is how the series go. You can have a question based on this, purely graphs, and I've told you all the graphs that are possible to be drawn in this particular case. Have you noted it down, bacha?
Yes, sir.
Now, this is a question that can easily come in your JEE. When I say JEE, it means JEE Main as well as JEE Advanced. Find which, find which, find which is which is K alpha, which is K beta.
First is beta, sir. K beta. Second is K alpha.
Well done. Do we understand how questions are framed?
Yes,
Huh?
sir. Yes, sir.
Hmm. Just understand simple things. Life is going to get simpler. Comes this one. Yes, my dear. Which is which? K alpha or alpha? Huh?
One K alpha, two. One is K alpha.
One is K alpha. Do we understand this or this has gone above our head saying bye bye, bye bye, bye bye, bye bye, I'm
Understood,
going.
sir.
Don't worry about me, I'm going. Have you noted it down, everyone?
Yes, sir.
Then that takes us to the last part of this chapter. And that one is known as the Moseley's law. Have you heard this term, Moseley? Have you heard his name, Moseley?
Yes,
Huh?
sir.
Who was he? Huh?
Owner of periodic table.
Founder of periodic table. And how did he find out the periodic table? No idea, sir. He just found out the periodic table. That is what we know, sir. We don't know how did he find out. This gentleman was actually studying what? Huh?
Sir, by using atomic number, he constructed the periodic table.
How did he construct it? That is what I'm asking. He was studying X-rays, my dear friend. Moseley was studying X-rays. He was studying X-rays, and while he was studying the characteristic X-rays, and he conducted a lot of experiments on a lot of heavy metals, he found out what? Found out what? He was studying the characteristic X-ray spectrum of heavier metals, and he found out that there is some relation between the frequency of those X-rays and their atomic number. Don't have to write everything. Don't have to write. This is just to explain. He studied the X-ray spectrum of a large number of heavy elements and concluded that the spectra of different elements are very similar, and with increasing atomic number, the frequency increases. The frequency increases. In fact, he found out what? That the root over frequency of this characteristic X-rays can be written as A times Z minus B. A times Z minus B. And this A and B do not depend on the metal. That is the most important thing. This A and B are actually constants. For any type of X-rays, this A and B are constants, and A and B are independent of the type of metal. That is important. A and B are independent of metal. This law, my dear friends, came to be known as the Bohr's law. Bohr's law? This law came to be known as the Moseley's law. Why I'm saying Bohr's law? Do we understand this?
Sir.
Everyone. Now, if you square both sides, you can write the equation in the form of squares. F can be written as some other constant. Let me call it as A also. Z minus B square. You can call it A, you can call it capital A, you can call it small a, it doesn't matter. A and B are actually constants. Do we understand this? Actually, you can find out the value of this A or A square, whatever you call it. You will say, sir, why I have not squared this A? This is again a constant. Sometimes you will find it. Sometimes you will find this Moseley's law written in the form of root of f. Sometimes you will find it in the form of f. Doesn't matter. If you understand, both the things will be looking similar. Now, this value of B is normally given to you. A is a proportionality constant. So you can write this is a proportionality constant. This B is known as the screening constant. This B is known as the screening constant. That is what you must remember. And normally this value of B will be given to you, but even if it should be given to you, but just for your information, the value of B is 1 for K series. The value of B is 7.4 for M series. Sorry, L series, not M. K के बाद L. And the value of B is 19.2 for M series.
Done, sir.
Now this Z minus B, this Z minus B is sometimes known as your effective atomic number. So you can also note that down. The Z minus B is sometimes known as effective atomic number. Do we understand this, bacha?
Sir.
Now, what I have here is now we have to compare it with something, and with what we are going to compare it. Now, if I write the what? If I write the formula of frequency, and I hope you can see it now. If I write the formula of frequency from Moseley's law, I can write this as a constant. Remember, it's a proportionality constant, my dear friends, into Z minus B whole square. This is the formula that I have derived from which law, bacha? I have derived this formula from Moseley's law. Do we understand this?
Sir.
I also have a formula from Bohr's model for frequency when a transition is made from any shell to any shell. Does anyone remember that formula, my dear friends? From the Bohr's model, when the transition is made from N2 to N1, what is the formula of frequency? You might not remember it, and I am not counting on that. It is this one: 1 by N1 square, 1 by N2, 1 by N1 square minus 1 by N2 square. Do you remember this formula? Bohr's transition from one N2 to N1. Do we remember this?
Yes, sir.
Now if I compare, what do I see? See, this Z square, the place of this Z square has been taken by this Z minus B ka square. Therefore, this Z minus B is known as the effective atomic number. Do we understand this, or this is gone about saying bye bye? Sir, bahut ho gaya. This Z is known as the effective atomic number, and whatever is left, my dear friends, would be the value of A. So what is A? What is the value of A? This constant that we are talking is equal to R into C, 1 by N1 square minus 1 by N2 square. That means this A does not depend on what? Right? A does not depend on what?
Atomic number.
A does not depend on Z. That means a type of element. Then what it depends on? It depends on C, sir. But C is a constant, sir. It depends on R, sir. R is a constant, sir. Then what it depends on? It only depends on transition, from where to where the transition is made. A depends only on transition. Again, this is an objective question in itself. I hope you are making note of this one. Huh?
Yes, sir.
Ah. Have you noted it down, bacha?
Yes, sir.
Now, this Krantikari, this revolutionary diagram comes from that Moseley's law, and everyone can understand this is a graph between root over frequency and your atomic number Z, and this is how the graph looks like. K beta comes on top, K beta comes first, then K alpha, and everything else I have already told you about. Yes or no? No or yes? Huh? Gone above it saying bye bye, bye bye, sir. I'm going. Don't worry about me.
Understanding, sir.
Ah. Oops. Everyone has noted this down?
Sir.
Huh?
Noted, sir.
Done, sir.
Then comes this correction, Moseley's correction in Bohr's model. And well, it is self-explanatory from where I see. On the left hand side, we have the Bohr's formulae. On the right hand side, we have the formulae for Moseley. And you can see in place of Z minus 1, that K series ka beta B is given as 1. So these are the corrections given by this. This is known as the effective atomic number. Do we understand this? It has gone above or at saying bye bye. Bye bye, I'm gone. Moseley's correction, we call it. What do we call it?
Moseley's correction.
Moseley's correction of Bohr's model. Introduce this Z minus 1 for alpha for K series. This is for K series transition. Have you noted it down, bacha?
Sir, 1 minute, sir.
Okay, sir. I'll give you time, sir. Shall we move on in life? Life has to move on.
Yes, sir.
Huh?
Yes, sir.
Hmm. Now, in most of the cases, the question that you are going to get would be of K alpha series. What is K alpha series? Huh? What is K alpha series? From where to where the transition is made in K alpha series? Everyone is looking at the back. Even a third class student can tell me from reading it. You are in the 12th standard. You must be saying it from what we have learned. Yeah. K alpha series.
L2K, sir.
Good. From L2K, L2K. And if it is from L2K, you can write the value of A. Remember, for all K series, the value of B is 1. Yes or no?
Yes, sir.
Huh? Ah. So this is the value of A for your K alpha series. You put, remember the formula of A. What was the formula of A? R into C. Root over 1 by n2 square minus 1 by n1 square ka root. Do we remember this A?
Yes, sir.
What, sir? Which one, sir? Here. If you write it in terms of frequency, this is A. If you write it in terms of root over frequency, it is root over this thing. Do we understand this?
Sir.
Oh, I think so. If I write the formula, for frequency as f is equal to f is equal to a times root over f is equal to a times z minus b, then the value of a becomes this. If I write the formula of frequency as a, because in the question it might be coming in both the formula, then the value of a is the square of this value. Do we understand this?
Yes, sir.
Yes, sir.
Because it's a constant of proportionality, beta, nothing else. So remember, when something is asked, in what way they are going to ask, that is what you must remember. Okay. Now I can write the general formula of K series, K alpha series. General formula of K alpha series. Now I'll show you question where you will see this. So if I write the formula as frequency of K alpha, then that can be written as R into C into Z minus 1, the whole square, into 1 minus 1 by 4. Do you understand how I achieve this formula? N1 is 1 and N2 is 4. So you can write it as 3 by 4 RC into Z minus 1 the whole square. Do we get this?
Yes, sir.
Yes, sir.
In very, very difficult JEE advanced, you can expect a question from here. Most of the cases, the question would be based on Moseley's law. It would be based on the graphs. In a very difficult JEE advance, they might ask you all these things because someone is bound to get confused. So they'll only ask you this in a very, very difficult JEE. Do we understand this?
Yes, sir.
Okay. Then we have this one. You have again the graph between intensity and wavelength. Which graph represents which one?
Z2 is greater, sir.
Which one?
Z2.
Z2 is greater. Why is Z2 greater?
Z1 is greater, sir.
Z1 is greater. Now, someone saying Z1 greater, someone saying Z2 greater.
Reason is intensity, the graph between intensity and lambda, sir.
See, you have now also seen the formula beta. Root over F is directly proportional to Z minus B, right? Have I given you the formula of lambda? No, I have not given you the formula of lambda. Okay, so I made a mistake here. I missed it. So let us write the formula of lambda as well. What will be the formula for lambda beta with this correction that Moseley has made? What will be the formula of lambda? And then with this formula, don't have to remember it. You will be able to understand it. What is the formula of lambda for this X-rays? Characteristic X-rays. What will be the formula of lambda if I talk about the formula of lambda? Lambda, let me write this K series formula only. 1 by lambda for this K alpha series will be equal to, yes, anyone?
R into Z minus 1 whole square.
R into Z minus 1 whole square into 1 minus 1 by 4. Yes or no?
Yes, sir.
Now, you can see 1 by lambda is proportional to Z. If Z is higher, lambda is lower. If Z is higher, lambda is lower. Yes or no?
Yes, sir.
Now give me the answer. 1 by lambda is proportional to Z minus B or Z minus 1. This is K alpha, so it is Z minus 1. So the metal with more atomic weight, atomic mass will have less lambda. Yes or no? For K alpha series. Who has the more? The metal with more atomic mass will have less lambda for K alpha series. More atomic mass will have less lambda. Atomic mass, lambda. More atomic mass, less lambda. Less atomic mass, more lambda. Do we understand this?
Yes, sir.
So
Yes.
what is the answer for this one, bacha?
Z2, sir.
Z1 is more than Z2. Do we understand this?
Yes, sir.
Do you understand the logic behind it? Do we understand the logic behind it?
Yes, sir.
Everyone, let me see if I can find a problem that has the potential of coming, because most of the problem that I see is too much labor intensive. Only those problems can come which can be solved in the given time frame. So this one, in the Moseley relation, root over frequency is equal to A into Z minus B, which will have greater value of constant A for K alpha or K beta? K alpha or K beta, which will have more value of A?
K beta, sir.
Why? There must be a reason.
Lambda, sir.
They're asking the value of A beta. Why are you saying lambda? Why are you saying lambda? A in this form, A is under root of RC into 1 by N1 square minus 1 by N2 square. Do we remember this? For K alpha, the value of N1 is 1 and the value of N2 is 2. So what will be the value of A for K alpha series? It will be root over 3 by 4 RC. We have already seen this, yes or no?
Sir.
You can find out the value of A for K beta series. Root over RC. 1 minus 1 by 9. Root over 8 by 9 RC. Which is more? Root over 3 by 4 or root over 8 by 9? Which is more? Root over 3 by 4? 3 by 4 is more or 8 by 9? You are taking so long to think about this. Okay, no one knows this, so I will not also tell this, because if I tell this, I'll have to tell you how to divide 8 by 9 and 3 by 4. I think we are old enough to divide 3 and 4 and 8 and 9. Yes or no? We can do that on our own, right? Yes or no? We can divide 3 by 4 and 8 by 9. How did you get this value of A? I'd already given you the formula here. Yes or no? No or yes? Chalo. Do we understand this? What is the answer? Chalo, we move on to the next question. And this is the next one. This is the only type of question that is probable of coming. They have asked it for L alpha series. Remember, for L alpha series, the value of B should be given to you. You can take the value of B as 7.4 and solve this question. These are the type of question that you can expect in an examination hall. The X-ray wavelength of L alpha, most probably they'll give you K alpha series. Of platinum, which is 7.8, 78, atomic number is 1.3 Armstrong. What is the L alpha of molybdenum, whose atomic number is 42? Give you 2 minutes to do this. Yes, anyone with an answer?
1 minute, sir.
Okay. It's all about calculation, my dear friends. Nothing else. Only calculations. Okay, I think I've given you enough time. Now, how we are supposed to do this, beta? Remember, this is L alpha series. For any series, I can write
1 by lambda directly proportional to
well, it's just a way of, it's just your calculation beta that I'm going to check. So I'll give you that equation, and then you can check whether your equation is same as this one or not. So I can write 1 by lambda as r into z minus 7.4. Remember, 7.4 wala question should not come. This is the only question I got from the previous year, so I am telling you, into 1 by, for L alpha series, N1 is 2 and N2 is 3. Yes or no? So it will be like this. Now this is constant for both the metals, whether you talk about platinum or you talk about molybdenum. So this and this are same. Yes or no? So I can straight away write, my dear friends, that 1 by alpha is proportional to z minus 7.4 square. Yes or no?
Yes, sir.
That means Z of molybdenum divided by Z of platinum will be equal to Z of platinum minus 7.4 divided by Z of M minus 7.4 the whole square. Yes or no?
Sir, option B.
It is
Sir,
5.41.
option A.
Option A. At last, I got an answer at the end of the day. These are the type of questions you are expecting in the examination hall. Remember, L alpha will not come. It will only be either K alpha or K beta. Because there, this calculation 7.4 just becomes too much to calculate. If it was Z minus 1, it would have been a lot easier. Yes or no? Do we understand this?
Yes, sir.
Okay, then, bacha, we are done with all types of problem that were likely to come in any JE that you talk about. There cannot be a problem that can come above this. And pray to God that in your JE main and JE advanced, you get a problem on this, because no one does this thing in so much of depth that we have done. So I hope that you get a problem here and you are able to crack it. Well, that finishes our class for today, and from tomorrow we begin with the much awaited topic, electrostatics, and we start our journey of electrostatics. Take care. Have a nice day. Bye bye. God bless you all.
Sir.